Okay, so let's go ahead and start with what we know. First of all, we know that it is an odd function and has a positive leading coefficient. So we know the graph starts from going down, it's going to make some turns, and then end going up. We have 3 zeros that happen at x is equal to -3, x is equal to 2, and x is equal to 4. So to go ahead and start this graph, and we have no multiplicities with this. So I know the graph is going to start going down and will cross the x-axis at -3, at 2, and at 4, and then end going up. So rough sketch of what this would look like, it's going to have to do something like this. It's going to have to come down and go up. When you're doing that rough sketch, you always graph from left to right, and you cannot cross the x-axis unless you have those 3 points. Now, what we don't know is what the rest of this function looks like. From the information, we can go ahead and rewrite this as x is equal to some value, and again, we know a is positive, we were told that. It's going to become x plus 3, x minus 2, and x minus 4. But because we don't know what a is in this case, we're going to leave this as just a rough draft, as a sketch of this graph, because we don't know how high or how low any of this goes. So we're just going to leave it like this for now. I have another example where we will have to go through and fill in those missing pieces. All right, so we have another example, and again, this is just a rough sketch because we don't know everything about this, but what we do know is it is an even function, and it has a negative leading coefficient. So that means we know the graph is going to go down, make some turns, and also end going down. We do know that we have zeros at x is equal to -3, x is equal to -1, x is equal to 1, and x is equal to 3. So when we're graphing these, just as a rough outline right now, what would this look like? Well, I know again I have zeros at -3, -1, 1, and 3. I know the graph ends going down in both directions. So when you're doing this, again, we're just doing a rough sketch of what this possibly could look like. I'm going to have to go through -3. I'm going to make some turn here. I don't know where that's going to turn. That turn could be down here. That turn could be way up here, or small. Doesn't matter. We would need more information. No, it has to go down. Eventually, it's the same thing. Don't know where this is going to turn. It could turn here. It could turn lower or higher, but I know I have to go back up, have to go through 1, and again turn, and then come back down. So this is just, again, a rough sketch because we don't have the entire function. We know we could write this function as f of x is equal to negative, whatever that value of a is, which we don't know, and that's why we can't make the whole graph. Then it would be x plus 3, x plus 1, and x minus 3. Oh, and another x minus 1 inside there. Let's do an example where we can go through and find those values next. All right, so we're going to need more than just a rough sketch with this. What do we know about here? I know with this first piece that x is equal to 0, but this has a multiplicity of 2, which means it will not cross the x-axis at that point. It's just going to bounce. The other two values are x is equal to -5 and x is equal to 3. I do that by just setting each of these parentheses equal to 0 and solving for x. All right, so next up, let's take a rough graph of this. From this, I have to find what my degree is. That's the next step. The degree of this polynomial is x squared times x times x, 1 for each of those other two parentheses. So this is going to be a degree of the 4th power, and it's going to be positive. So that means the graph is going to end going up and start from that direction both ways. Now, I have a 0 at -5. I have a 0 at 0, but remember, this even is an even multiplicity, so I always draw those in boxes because that's not going to cross that x-axis. And again, I know that because the 2, the exponent of the 2 here, tells me that's an even multiplicity, so it will not cross. And then the next 0 I have here is at 3. Now, as I'm following this graph, I'm going to go from here. I'm going to come down, cross the x-axis, come back up. I can't go through this. I can't go through it. I have to go back down and then go back up. So the rough shape of this graph is going to take this kind of a W shape. It's going to look like this. What I need to find, though, before I graph it, is I need to find out what's going on here and here. I need to find out how high or low that is. So let's go ahead and plug in 1 on this side and -1 on this side and get another value so I can make that W shape. That's just a standard table of values. Plug in what happens at -1 and at 1. Watch your signs here. That's going to be -1 squared, -1 plus 5, and then -1 minus 3. And all of that's going to equal a -16. I'm going to do the same thing for that positive value of 1, and that's going to be 1 squared, 1 plus 5, and then 1 minus 3. And that is going to give me a -12. So let's go ahead and graph this. So at -1, that graph would be -16, and at 1 it would be -12. So now I can go ahead and fill in the rest of this graph. We'll come down, bounce up, and then go back up. All right, this is the last one that we're going to do with this one, and there's a lot going on with here. So we're going to go ahead and start with the degree, which is where you should always start, and the leading coefficient. So if I look in the beginning here, there is a negative right there, so I need that. So that's going to be a -1 on the outside. Then up here I have, this is x, and if I multiply that out, the leading term for that would be x squared. Then for the next term, that would just be an x. And for the last term, that's x, but that one will be multiplied to the 3rd power if I multiply that out for the first term. So that means I have a -x to the 2, 3, 4, 5, 6. So that tells me I have a negative even graph, which means the graph is going to have this rough shape of going down, making its turns. The number of turns, again, possible, the max number of terms is always going to be 6 minus 1, or in this case, possible 5 turns. So let's go ahead and set up the beginning portion of this. You have your x-axis. I have zeros. All right, let's go back up to the very beginning and find out where my zeros are. So looking at the first parenthesis, that x plus 4, I set that equal to 0. And my first 0 is x is equal to negative 4. But remember, that is a multiplicity of 2. So it has an even multiplicity. So at negative 4 over here, I draw myself a box. And the reason is because I want to make sure I remember it does not cross the x-axis at negative 4. It comes down and touches it. And that happens anytime there's an even exponent out there. All right, the next group that I have is x plus 1 is equal to 0, or x is equal to negative 1. So it will cross at negative 1 because there is no multiplicity with this. There's nothing that's touching there. So I have a 0 at x is equal to negative 1. So it will cross the x-axis at negative 1. And the last one that I have is going to give me a 0 at the last parentheses, and that's x minus 2 factored. This is an odd, so what happens there is it will be a 0 at x is equal to 2, but remember, because that is odd, it's going to go ahead and get flattened out. So over here at 2, I'm not sure which way it's going to go. It could either go like this, or it could go like that. Let's go ahead and find out. Now, how we're going to find out is, remember, we're going back to the fact that this is an even negative. So it means it's going to start going down and end going down. I always go, when I'm doing my graph, I go from left to right. So I'm starting here. I'm going to come up, touch this, not go through it, come back down, go through 1, go up, and then I'm going to come up and come down and kind of flatten myself out over here. Now, we do need a couple things to do this. So we need a couple of different values. What happens in between negative 4 and negative 1? I don't know. So we need to find that point. So let's find a point at, let's say, negative 3. I also need a point in between, negative 1 and 2. So let's go ahead and give us a point. For that one, we're going to go ahead and graph a 0. So when I plug those in, what do I get? Well, if I plug in 0, so let's go through and do that. Remember, I'm plugging it into the function. So what I'm saying is, where is f equal to negative 3? And that happens at negative 3 plus 4 quantity squared times negative 3 plus 1 times negative 3 minus 2 cubed. And that's hugely small. That happens at negative 250. So that's going to be way out of our scale. Going to be way down here somewhere at negative 250. The next one that we're going to do is f of 0, which is negative times 0 plus 4 squared times 0 plus 1 times 0 minus 2 to the third power, which is also hugely off my scale. That's going to be 120. So let's go ahead and get rid of this work, and we can go ahead and graph this. It's going to start going down, come up, bounce, go all the way down here to negative 250, go up, go through, and then finally come back and go down. In the next section, we will discuss how to graph polynomials that are not factored.